Thank you very much. Arigatou gozaimasu. I'm going to talk today mostly about my work at DARPA before, and it is really a very exciting thing. I've been involved with Japan actually for a number of years, and as I tried to first understand the country, I read this book. Of course, this book is very famous, and Nitobe-san, of course, had a wonderful phrase, which is that he wanted to be a bridge across the Pacific. And so what I want to talk to you about today is the possibility of business and technology, and in my case, collaborative autonomy and robotics, sort of a mouthful, being part of that bridge. And so, as was mentioned, the inspiration for the work that I did while I was at DARPA was the disaster in Fukushima. And of course, I do not need to tell any of you any details of the disaster, but in particular, as you know, there were 3 explosions that occurred in the reactors there. And an analysis of what happened shows that during those first few days, the first few critical hours, there were times when some kind of intervention to release the built-up hydrogen gas could have prevented the explosions. And so this is the essence of the work that I did at DARPA with regard to the challenge. When the disaster struck, many of us at DARPA who worked in the robotics field immediately tried to help. In particular, there were 3 robots that had been developed at DARPA before for use in defense. One was called the PackBot, the other one was called the Talon, and finally the third was called the Thunderhawk. It was a flying robot. And immediately I got in touch with all 3 companies that made the robots for us and arranged to do some calculations of what the radiation resistance of the robots were, and also helped them to get the robots to Japan as quickly as possible. At the same time, Professor Tadakaro at Tohoku University worked very hard to get his robot Quince also to the disaster to try to help. These robots were good for inspection, but they could not actually make that much of a difference. They could not turn a valve. They could not release the high pressure. And so, unfortunately, we were not successful in preventing the explosions. We were not successful in preventing the exclusion zone, which now exists around Fukushima. So immediately after, I began with some colleagues to think about a challenge. What could DARPA do? What could the world do to try to prepare for the next disaster? Because when a disaster strikes, it is too late to prepare. You must prepare before. And so we looked back and we thought about other challenges that had worked before. One particular one, 1795, from Napoleon, of all people, said, I need preserved food. And so, in fact, a number of years afterwards, there were 2 people that won the prize. One for putting food in a jar that was sealed, another in a can, and thus was born the invention of canning and preserving food. I know, of course, that the invention of sushi had the same problem to solve. But this is how the French solved it differently. DARPA had another problem, which was the problem of roadside explosives, roadside bombs. And so we needed to develop autonomous cars that did not require a driver. And so in 2004, 2005, and again in 2007, we initiated challenges for anyone who wished to try to develop an autonomous car. And while the application was initially for defense, now the application 10 years later is turning out to be completely civilian to try to reduce the 1.2 million deaths that occur from car accidents every year. I want you to think about that number, 1.2 million per year. That is over 3,000 people every day who die in car accidents around the world. It is astonishing. And so these kinds of challenges have the potential for helping with these tremendous societal issues. So I started a new challenge to try to develop robotics that could be used during a disaster to make the disaster less severe. Here is a chart that shows how we organize the different teams, software teams and hardware teams, different phases of review. First, we had a challenge and simulation, then a phase 1 challenge, and then a phase 2 challenge. The details are not important. The key is that DARPA invested $100 million of US government funding in order to run this challenge. The different tasks we did were for robots to help in a disaster zone, just like the accident that occurred at Fukushima. And you see here the 8 different tasks the robot had to do. These were directly inspired by what happened after the earthquake and tsunami in Japan. We even needed to emulate problems that occur in all disasters with communications. And so in our contest, we added a degraded network between human beings and robots to make sure that we made this realistic. We made the communication much worse than the worst cell phone call you have ever had. A big problem we had to solve, and one that I particularly wanted to solve, was how to get the engagement of Japan. Of course, Japan has a pacifist constitution, and many of the universities have a ban on military research. We respected that tremendously, but at the same time, in the United States, international disaster response is one of the missions of the Department of Defense. So how could I engage the wonderful robotics talent in Japan in a contest that was run by the US Department of Defense? And what we understood and explained to our colleagues in Japan is that some defense is military and uses arms, the force of arms, and some defense is non-military and does not use the force of arms. And an example of such is Operation Tomodachi. And so we worked very hard to discuss with the government and the universities this nuance of defense, that there are different kinds of defense, and in the United States, disaster response internationally is done as part of the Defense Department. And of course, the help of the Defense Department after 3/11 was an example of that. Here's what happened as we led up to the first of the contests.
I am Narito Suzuki, Chief Operation Officer of Shafting. And he's our team leader and our CEO, Dr. Yuto Nakanishi. As you see, it's a bipedal robot, and our robot characteristic is high speed and torque. The one of big problem of humanoid is weakness of robot, and but he built a special motor driver and water cooling system, and it enables our robot can generate a very big power. Second is the robot is robot can walk very stably. In this DARPA trial, there are very difficult program to walk stable and on the unstable terrain that Dr. Nishiaki's algorithm and Urata's power and high motor driver can enable such very stable walking. Third is the specialty of integration power. A lot of team members come from same robotics laboratory from the University of Tokyo, and we are almost all graduate, and we shared a very wide experience of robot integration and software, both software and hardware, and have shared a lot of experience, and that experience enabled us to develop robots. And I think it's a very important thing to get a win.
So what was wonderful there, of course, excuse me a second, I will go back, is that he also modeled how the robot moved. So that was very, very good. But let me go back and show you a little bit more about what happened at the contest itself. This will be a very short clip, and then I'll go on to these results. So here we go, and... So this is a tiny little clip out of a much longer video, but the results are shown here. Team Shaft ended up in first place, above many, many other teams, both from the United States, from Korea, from other parts of the world. And what they did, what was really essential, and Professor Inaba, their professor, is here, is I think, if I can maybe put in a plug for Toyota, it was Kaizen. They worked very, very hard. They made sure to practice and practice and improve and improve and improve and improve. And it was a remarkable Japanese style which led to tremendous success. In fact, the success was so good that Google went and bought the company. Now, the company here was a spin-off from the university. And here, after their success in the trials, thanks to the embassy here in Japan, I arranged to have the president, when he was visiting anyway, to congratulate the winners. But this actually spurred a tremendous kind of a renaissance in the robotics field. And this renaissance continues today as many, many companies are very, very active in the field. After that, the Japanese government and the Korean government came to us in Washington, and we had many meetings where we worked collaboratively together. And in Japan, METI and NATO worked together to fund several of the Japanese teams moving forward to work in this field and to be part of us. So our third phase of the challenge looked like this. We had teams from all over the world, and in particular, we had 5 teams from Japan. Really extraordinary. One of the robots was this one over here, and it is from Team Aero, and I think they have a small demonstration that they can do. We'll see if it works. This is a prototype, so I want you to, aha. Ah. How many of you have ever watched the Miyazaki movie Castle in the Sky? So in that movie, there's a wonderful thing about robots and flowers working together. While that is going on, I will wonderful. Great. So if I could have my slides back, please. The finals looked like this. This was the third phase.
It's the third and final round of the DARPA Robotics Challenge. Teams have spent years designing robots that could aid in an emergency and potentially do much more. And over the next 2 days, they'll take them through an obstacle course meant to mimic a disaster zone. It's a chance to win millions in prize money, and more than that, show what their robots can do.
It's easy to design a robot that can handle a specific task. There's police bots for bomb disposal and things like that. Where we aren't is general purpose robots that can do a lot of things really well.
This is the Florida Institute for Human and Machine Cognition. Their Atlas robot fell twice during the first round, and after some overnight repairs, they're getting ready for their final run. The robots have an hour to complete 8 tasks. First, they have to drive a vehicle down a dirt road, avoiding obstacles. Then they have to get out of the car, one of the most difficult maneuvers. Then the robots open a door and walk through it. Once inside, communication starts to break down. The robots have to act more autonomously. They have to turn a valve, then cut a hole in a wall using a drill, then complete a surprise task, either flipping a switch or plugging a hose into the wall. Finally, they have to get over a pile of debris and climb a set of stairs.
So those were the tasks that we had for the finals. And here's what happened. This time the Koreans won. And of course, this was a great disappointment to the Japanese. As you might expect, there is a great deal of rivalry. But actually, there were many teams, both from Korea and Japan. And on average, the Japanese teams did a little better than the Korean teams. But there was one Korean team that happened to be a standout. What did they do? they adopted the strategy that the Japanese team did in the previous race of incremental progress and Kaizen. And so I think that we have a whole lot of amazing lessons to learn from Japan. We got a huge amount of press. It's only the beginning of the work that we are to do. And I want to talk now, wrapping up, about 3 big opportunities that I think exist for a bridge across the Pacific. The first and most important is aging society. These graphs over here show the demographics that are going to occur in the United States. Presently in the US, 13% of the population is over age 65. And in 15 years, the number will go from 13% to 20%. In Japan, of course, I believe the number just hit 25%. And in maybe 15 to 20 years, the number will reach 40%. Very, very difficult problem. Who is going to take care of us as we age? How can we age in our homes and have dignity and have good quality of life? And I think that these robots that you see here, even though they are prototypes and clearly just starting, here is another one. I will put in a small plug for Toyota. This is one we are beginning to develop, and it's a prototype, so just standing here, called the home service robot. We need this technology to help take care of us. And the reason I have this slide is that Japan will face this problem in a more difficult way than the United States, but it is a perfect opportunity for us to work together to try to resolve it for both countries. The next slide is climate change. This is a very, very difficult problem, and climate change is directly linked to future disasters. Now, of course, earthquakes are not part of climate change, but there will be other disasters that are a direct result of climate change. And we will need robotics in order to address both of these things. And then finally, something that is the strength of Toyota is manufacturing. Robots are very complex, both in their mechanisms and also in their control, in their software. And so we must find a way to have robots and other complex machines be produced in the same way that nature produces all of the wonderful things that we have. So I think these 3 things are just examples of ways that the US and Japan can work tremendously together. I do not have time for questions now, I understand, but I want to urge you, if you have questions, to find me afterwards, and I would be glad to answer them. Thank you very much.
Thank you, Dr. Pratt.